surds, our irrational number. They are any number that includes the radical symbol and cannot be calculated exactly. That's more to the point. So for instance, the square root of 4 is not a surd because we can simplify that. It's 2. Our surd laws, okay, allows us to multiply, but probably more importantly, going backwards allows us to simplify surds. There's a similar one for division, and when we're squaring, well, they cancel each other out. Squares and square roots are opposite of each other. Root 50, the idea being what we want to do is find a factor that is a perfect square. Factor of 50 that is a perfect square is of course 25, 5 root 2. We talked about this one before. So root x cubed we saw becomes x root x because of course we can rewrite x cubed as x squared times x. And we get x root x. Provided, of course, what?
X is positive.
Yeah, if x was a negative number, you couldn't do that, could you? In fact, if we were to draw y equals the square root of x cubed, we'd see that negative numbers are not in the domain. Root 5 on 4, well, we can't find the square root of 5, but we certainly can find the square root of 4. That's where the second law comes in handy. So we can rewrite that as root 5 on 2. Root 20 on 9, well, both of those can be simplified. The top one goes to 2 root 5. The bottom, of course, square root of 9 is 3. Surd arithmetic. Very similar to the first bit of theory that we projected up when we were talking about algebra. Remember we said like terms can be added and subtracted, unlike terms cannot. Well, the reason for that is just like a pronumeral, a surd is an unknown. Surds obey a lot of those algebra rules. Now we collect like terms. Well, in this case, we collect like surd. And we get 3 root 3 plus 8 root 2. Binomial expansion. First outside, inside last. And nothing there groups together, does it? No. Difference of two squares. This becomes really important because they are, of course, what we call conjugates. Conjugates. It's nice because it can turn irrationals into rational, if you think about it. We're multiplying an irrational number with an irrational number and we end up with something that's rational. 2 minus 1 is, of course, 1. And a perfect square. And in this case, the 4 and the 2 add together and we get 6. So all of those things we did with algebra we can do with surds as well.